Okay, enough of that. Good afternoon. I can't talk to these people. Good afternoon. Welcome to my talk. This is my 10th LISA talk. I'm so glad to see you here, and I'm so glad that you understand that this will not be just a passive talk, and that you'll be participating, and I'm really glad that you're here. So, in case you're curious, this is the talk I'm going to be giving. Where's the Kaboom? There was supposed to be an Earth-Shattering Kaboom. I'll introduce myself at some point if you like. But I feel it's really important for me to confess first. I want to be clear to you that I have lied terribly to you, and I feel not so bad. I think if you were here because you were expecting an entire talk full of explosions and destruction and I don't know what, I won't be providing that to you. I will give you a little bit of gratuitous implosion, but not a lot of that. And if you're here just for that sort of stuff, I apologize profusely to you. I'm hoping to actually give you a way to think about the systems that you have that you want to figure out how to either get rid of, demolish, destroy, and more importantly, how to design things from this point on such that it's easier to do that. So if you are also coming here to ask, how do I get rid of that Windows 95 thing in the closet, or the Windows 95 thing in the closet that is running my MRI machine, which is even scarier, then I'm not going to provide that to you. I'm going to try to provide to you ways to think about stuff that I think will be useful to you. Okay, so so I just want to warn you, like, we understand. Okay, this is where we're going to go. Okay, so the other thing that I feel really compelled to tell you is that you should be careful because some of what I'm going to tell you is absolutely wrong and incorrect. Okay, and it will be totally up to you to decide what that stuff is. The reason why I'm going to be telling you things that are somewhat wrong and incorrect is that the analog or the analogy that I'm trying to provide to you now falls down in certain places. And I am well aware of those places. And I hope that, afterwards when you talk to me, you will call me out for those places as well. I'm well aware of that because it is the case that, quite frankly, software and the physical world, I don't know if you've noticed, are different. They have different things about them, different characteristics to them, and I am attempting to do what I do at these talks. This is my 10th LISA talk. I don't know if I mentioned that, which is pretty amazing. I'm so honored to be here. I like to give talks where I try to bring things from outside our field into our field to enrich the way we think about things. This is another one of those talks, but I might be wrong. And it's also important to note that the economic incentives around this are different. It is the case that you want to spend less time and less labor and stuff like that, but it is not the case that if you were to do a good job of destroying your code, that you can take this code and sell it to somebody else so they can build something else with it. Or at least I hope that's true. Right? Which is different in the demolition world because in theory, an important thing you want to do is try to recover as much as possible because then you have all this material you can use later. I'm not clear that your old code will go for high amounts of money on the open market, and I really hope that's true. And here's the other thing where things go kind of screwy. I am going to talk to you about this in the abstract. I am truly going to talk to you about the ideals of demolition and the ideals of software development and software integration and system administration and DevOps and SRE. But these are people, right? So there are ways that you're going to say, but the people are evil or they're doing the wrong things and stuff like that. I'm going to leave all that stuff out. I know it. I know it already. So some of what I say is going to be wrong. Okay, are we ready to start? I can't tell. Are we ready to start? Yes. Excellent. Okay, so here's my contention. What I want to tell you right now is that we are terrible. The people in this field, and I have been in this field for some 32 to 33 odd years, are terrible. Specifically, we know how to build things. We are awesome at building systems. We are awesome at integrating stuff. But we are absolutely, I think some of the English folks in this room would say pants, but maybe rubbish. Maybe there's another word for that. Shite, is there a better word? We're just terrible, 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 terrible when it comes to destroying things or decommissioning them or demolishing them or retiring them because I lost the D's, but another R just to keep the alliteration, or removing things. Okay, we're just terrible at this. Like, you know that, right? You go back to your workplace and you look around and you see all the things that should have been gone yesterday that are still there. And that's because we're terrible at it. And if you think we're bad at that, I want to say that we have no idea how to build things that are easy to get rid of. We just don't have any idea how to do this. We're just bad at it. And so the question is, who does? I'm sorry. I don't know how that got there at all. And if you want to argue with me later about which the best doctor was, I'm going to really say Tom Baker. That's just telling you now. Okay. But the question you might ask is, who actually has any idea about how to build things or how to demolish things? And specifically the people that do it for a living. Right? The people that spend their time that you hire to come take down buildings or to take down your bathroom. I had my bathroom demolished to get it reconstructed, or take down entire buildings. This is an interesting little film. I don't know, and I'm going to let it go. I want to see if you pick up what's interesting about this. This is, I think it's Demolition of a Wall. There's a French version for that, but my French is terrible. By the Lumiere brothers. And one of the things that you might find that's really interesting about this thing, this is just an offside comment because I love giving those offside comments. One thing you'll notice about it is this. So what do you notice about that film, just for fun? Yeah, it's now going backwards. That's not my doing. This was the very first film that was ever created where they did reverse motion. It's true. It's true. It exists. Anyway, okay, so what I want to talk about is specifically what we can learn from the people who do demolition for a living, okay? And I think that they have a lot to tell us, and if you don't believe me, well, you can trust Ed Asner.
When people think of demolishing buildings, they think of loud explosions called implosions, and giant wrecking balls slamming against concrete. Yes, that's part of the story, but only a part. In truth, demolition contractors are skilled business people performing a valuable service, using the latest in equipment and techniques. They create new space for useful buildings, remove dangerous and unsightly structures, preserve historical facades, and recycle quality material. And they do all this in a safe, environmentally responsible manner. I'm here today to demolish a few myths. Myths about what demolition contractors actually do and how they do it. It may surprise some of you to think of building dismantlers as creators, but that's what they are. They create the space to build our new schools, hospitals, homes, and office buildings. They create ways of reusing brick, steel, concrete, asphalt, and wood. And they create jobs. In spite of what we may think, implosions are used in a very small percentage of demolition jobs. When implosions are used, weeks of preparation can be involved to ensure that everything is done safely and efficiently. But I do have to admit, imploding buildings are rather dramatic. In most demolition jobs...
Okay, that's all the implosions you get. Sorry. And they create jobs. I love that. I can't get enough of that. Anyway, so what I'm going to do is be talking about stuff that's not just sort of like when we talk about this, people use different words, lots of the D words, decommissioning, deconstruction, disassembly, that sort of stuff like that. So what I'm going to do is talk about this. Oh, and here's another little aside. You realize that implosions are misnamed, right? They're not implosions, nothing implodes. It's a process where you take and use explosives very carefully to take out the structural integrity of the building, usually at the bottom. And usually what they'll do is they'll also implode one of the two layers closer to the top to make everything crush better when it goes down. And what you do is you take out the structural integrity and it all falls down. Or you aim it some way. You can aim your explosives. And that's a lot of stuff. Anyway, I know too much about demolition and destruction now. We can talk about this later. It's a really fun thing to geek out about. Okay, so some of the qualities of demolition versus construction are everyone thinks they can do it. right? When I talk to the demolition companies, they are careful to talk to me about, pardon this expression, this is the term, two schmucks in a truck that you can hire to come swing, a sledgehammer for you. But we're talking about the people that do this professionally. Another thing is this does not work well with others. And here's a slide from another NDA thing, which, as a safety issue, when a structure is in the process of being demolished by a machine, that contractor must control the demolition area exclusively. Now, I hope you're starting to get that feeling like maybe there's an analogy going on here. Maybe he's trying to tell me something, because maybe he is. I want to say also that one of the things that you typically work with that's interesting about demolition versus construction is you don't always know when you're walking into that system, to that code or whatever, how it was built. In fact, more often than not, you're coming to something that you have never had any control over. You have nothing there. And specifically, you don't actually have any idea of what they built it with. What are the dependencies, for example? Like other stuff like that, to quote a previous speaker. So there's stuff that's interesting about that. Now, one of the things that was pointed out to me that's important for you to know about demolition, how demolition is not done, again, this is by people that do professional demolition, is that stuff you see on HGTV where there's this little montage where the homeowner swings a hammer into a wall and then suddenly they cut and the wall is gone. It's not the way it works. And one way you know the way it works is that if you're doing real demolition, you don't actually hit anything into the bay of the wall. You are trying to pull it out of the wall. So this is one way to know. So it's not going to be any sort of montage. And in fact, I'm not going to suggest you go back to your company and if you just had the right 80s training montage, everything's going to be great. But that could be true. Okay, so some of the keys to the process that I want to point out is that demolition is often a process of reverse engineering, where you are walking into a situation and trying to figure out, how did they build this? So I can figure out how to take it down. What materials were used? What layers are part of it? When was it done? All this sort of stuff is a reverse engineering process. And specifically, one of the things I thought was kind of brilliant was the notion is that the process is a last on, first off thing. You are stripping layers in the reverse order that it was put on. And this may be true for your systems as well. And the other thing that they also pointed out is the thing you don't do when you talk about last on, last off is you don't take away the floor. The floor is the last thing you take out for semi-obvious reasons, including the fact that you don't want all the crap to go down into the next floor below you is typically a problem. Okay? Whoa, sorry. That was the analogy warning. Do you want me to go back? Yeah, you probably don't want me to go back. Okay, sorry. Okay, that was back. Sorry. Back. So that was, unfortunately, for better or worse, that was the analogy warning device. What I'm trying to tell you is that the stuff we're going to be talking about here is meant to spring up ideas in your head. And sometimes I will spoon feed them to you, but mostly I won't. I want you to figure out how this connects back to your world and when you build stuff and stuff like that. So, and I know they're here, and I think if I show you these things and say to you, are these applicable, for example, to your world in the land of software? You're going to say, yes, they are. And in fact, I'm going to show you other examples that come out of the building industry, and you're going to be like, that sounds like somebody from computers wrote it, right? And I want you to keep on having that nagging feeling like, oh, I've seen this before, or this makes perfect sense to me. That's my goal here. Okay, so what I want to do is I want to go into sort of that question of how do we take stuff down? How do we build stuff that is easy to take down? And the place I want to start is it turns out there's a movement called sustainable demolition or sustainable deconstruction. And the idea is that it's sustainable. And this is a definition of what sustainable development means that I love so much. It says development that meets the needs of the present while compromising the ability of future generations to meet their own needs. Right? And if you can think about how you, when you're doing the building that you're doing, if you can think about how to do that, you're in a good, you're going in the right direction, right? And I think that's important. And in fact, there's a lovely report designed for Disassembly. There's a URL down here, and my slides will for sure be available to you whenever you want it. About this, like how do you, like one of the examples of doing design for deconstruction or disassembly. Now, the question is, since we're talking about how do you make things that are easier to take apart, what makes that easier? Well, one thing that's really important is that you have some sort of transparency, right? That you actually know what is there in your software, in your systems. That you can really tell what it is. Another question is, to make it easier, is the way things are built in a regular fashion. Things that are super idiosyncratic tend to be really hard to figure out what's going on there. Simplicity, right? Like the more simple the way your software and your systems and your et cetera are constructed, the more likely it is going to be easy for you to take them apart later. A limited number of components, right? That makes sense to you immediately, right? And this I thought was interesting. Easier to dismantle structures that are composed of a smaller number of larger members than a larger number of smaller members, which is kind of like, would you rather be pecked to death by 100 horse-sized ducks, or or one duck-sized horse or something? Anyway, you understand what I'm talking about. But so this is this is just an interesting factoid, right? Like that sometimes having your software be made out of smaller numbers of large things is perhaps potentially something that will make it easier to take it apart later. Easily separable materials, like if you can rip your things apart, that's true. Other stuff like that, simple regular layout, we kind of talked about that. I like this also, and you can immediately see how this is applicable to the digital world. When mechanical systems and envelope components are intermingled with structure, it is difficult to replace these systems during the building life and difficult to extract the structural elements at the end of the building life. The idea is that you have layers, right? If you have everything that's all spaghetti, it is very hard to take things apart. Common standard shapes and connections, minimize number of different member sizes. Use removable fasteners, not adhesives. The question I would ask you is, what are the components in your world that are adhesives? Right? I do believe that we have digital versions of adhesives. Using multiple types of things, right? 14 different frameworks can also make you crazy. And this I thought also was interesting, is that the suggestion is use salvaged materials. If you are building with salvaged materials, then it's very likely that later on you can get value out of them later, that the likelihood that you can reuse them later is much higher. And I'm not going to read all these. These are also from one of those reports, 10 key principles for design for disassembly. But I will just do this and say that if I were to stick this in front of you, and again, this is just building, and said to you, is this software? Document materials and methods for deconstruction. Have a deconstruction plan when you write your software in your systems. Have you thought about doing that? How I'm going to get rid of this later in your documentation, in the stuff you're writing? You document that you have a design doc. Do you have a deconstruction document? I bet you don't. Could you? I bet you could. Am I going to answer all my own questions? I bet I will. Design connections that are accessible. Make it so that the systems you build have connections that can be pulled apart, that you know where they are. Separate systems. Separate the different parts of it, right? Design to the worker and labor separation. So this is super interesting to me. This is the comment that is basically saying, if we're going to build a building, I should build it in such a way that I am thinking that humans can take it apart. Right? That they will have the access to do it, that I'm building it in such a way that I can see a human doing that. If you were to build your software in a way where you could see the person who could take it apart, and that person wasn't, a 10x engineer or something, right? Then that's a good idea. Simplicity of structure and form makes sense. Interchangeability, right? So when I put this in front of you, I'm just trying to say, start thinking about this sort of stuff. It makes immediate sense when you read this, right? Am I the only one who this makes sense to? Because if I'm the only one who makes this sense to, then that's a problem, and I've done a bad job. But I think so. Okay, so I'm going to go a little bit more sophisticated and take this up another notch. There is an excellent book by Stuart Brand called How Buildings Learn, What Happens After They're Built. It was written in 1994. I think it's been updated a little bit since. And in fact, there's a YouTube playlist of a TV show that they made about this. And in it, he comes up with what he calls the 6 S's, which he took from a guy by the name of Duffy, that says, first you have the site, the place where it's being built, right? We understand what the site is? Right? And what is the context for that? Could it be the infrastructure? Could it be Amazon? Could it be just trying to tell you. Structure, that's the thing that you put up, right? The actual structure of what you're constructing in a building. There's the skin, right, which is the outside of it, how it is enclosed, right? So far, so good. That there are services that run within this, electrical, power, plumbing, etc., that are plumbed through this sort of stuff in a building. There is the space plan. How am I going to set the walls in this building, right? And then there's stuff. And if I had more time, I'd be playing you George Carlin's monologue about this. If you haven't heard George Carlin's monologue about stuff, please go back and listen to it immediately after the next speaker, who's going to be awesome too, I'm certain. But here's the interesting thing. These things all take place at different time scales and last for different time scales. Site, in theory, where you're at, the place you're at, most likely that place, that thing you're building on will be there forever, for some value of forever, right? The structure that you might put up is going to be somewhere between, it's going to last somewhere between 30 and 300 years, depending on how amazing a builder you are. The skin that you put around the building, about 20 years. The services that you go through, because every once in a while we have to replace things, 7 to 15 years. The space plan, where the walls are, okay, is going to last for about 3 years if you're a commercial site in moving stuff around, or at home maybe 30 years before you actually do something with that. And then your stuff is, who knows, right? Like how long that stuff lasts. So why is this interesting? Why is it interesting that these are at different temporal scales? The way that Stuart Brand talks about it is he says that what we have here is shearing levels of change that are in constant friction. All of these things are moving against each other in a shearing force, right? Because they're doing it at different temporal scales, right? Shearing layers of change that are in constant friction. Now, let's talk about this, because this is really interesting. I'm going to read this. I don't usually put huge chunks of text on a slide, but by focusing on the points of connection between separate systems that have the most disparate service lives, designing for demolition, disassembly, can have very practical and economically valuable impacts. Don't care about that, but keep on going. Repair and replacement cycle information can be used to identify the most critical connections between building assemblies and components where the greatest lifespan friction will occur. So what I'm telling you now is that one way to look at your systems is where are the shearing forces of shearing layers of change that different parts of your systems will last for different periods of time, and where do they connect and where is the friction? Because if you can pay attention to that, that might give you some idea around how you do demolition of your stuff. Okay? That's the big idea I'm giving you today. Like, I think this is a really brilliant way to look at buildings, and I think it's actually a pretty good idea for how we might think about our systems, however you choose to define that. Okay, so what did I just give you, right? We're coming to the end of this talk. What I just gave you is just a way of saying, like, hey, if I were to go back to my workplace, then I might be able to look at the systems that I build, the software that I built, the stuff that I integrate, and I might look at it in a different way. I might look at it how a demolition person would look at it. I might think about first on, first built, first, last off. I might think about making sure there's a structural floor under it when I'm taking it apart. I might think about sharing levels of change, and that might get you someplace. That's what I'm hoping that you'll take back today. So I would really like to talk more about this with you. I have so many more things to say about demolition and other stuff like that, and would love to chat with you. And recently, having been laid off last Friday, if you'd like to talk to me for a long period of time, you can hire me, and that's how you find me. So I want to thank you very much for your attention. It's awesome to be with you here at LISA. Thank you so much, and that's my talk. I brought us in with exactly 5 minutes to go before the next speaker. I can take probably a question, if there is a question, or a comment, or an obscene gesture, whatever would make you happy. Would be totally fine. Practice that.
And please go forward to the microphone for the
Please
question.
come forward to the microphone, so says the voice of God.
Hello.
Hello.
Thank you.
Hello. Let's practice that. Ready? Hello.
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 Okay, go ahead.
Hello.
You mentioned on an earlier slide.
Yeah, I'm going to stay away from this thing so it doesn't feedback. Go ahead.
That it's easier to deconstruct larger components than many smaller components. In a world of microservices.
In the world of microservices.
What does that look like?
Yeah, so that's a great question. So that's the thing. So the argument from the building industry is that it's easier to take apart a smaller number of large things than it is to like have a bunch of stuff that you have to take apart. I've thought about this. I think microservices are well suited to some of what we're talking about because there are bounded contexts, right? And where they connect is exposed in a way that isn't usually exposed. And I think that works in your favor. However, having a lot of them, and in theory having a smaller thing to take apart is great. But this is when they're talking about taking down an entire building, right? So the question is, if you were going to drop an entire application or an entire thing that's made of a bunch of microservices, then that might apply. But I don't think what this is trying to say is talk about the individual components of that sort of thing. This is about taking down the entire thing. So if in fact you had lots of larger things and you could get your head around that, right? Because this is one of the complaints that people have about microservices. So many things, how do I know what they all are and what's going on, right? And this is just saying like, yeah, that's true. And acknowledging that is what I want to say.
Okay.
So,
thank you.
Hope that helps. In a world of microservices. Well, thank you very much for this talk, this time to talk to you, and please come see me afterwards, and hire me.